Hello and welcome to Camosis Learning Tutorials. In this video we are going to learn about design and analysis of steel structure with connections in Camosis. We try to design a simple steel structure, so that we can discuss as many tools and options as possible quickly in Camosis. Let's start by modifying the default grid lines. Simply double-click on grid lines, which brings us to the grid editor window. Now, edit the grid spacings by simply adding the grid spacing for X, Y and Z axis. We can also control the display of each grid levels about Z axis using the checkboxes. Simply click on OK button to apply settings. Let's set the project design preferences. User may require to use project preferences to set design codes for member and connections design to be done in the model. Also, user can set general deflection limits for beams, columns, girts, bracings and many other members. Let us specify the material grade for steel. User can also specify the materials grades for steel plates as per their thicknesses. This will allow the user to use different grades of materials depending upon the materials availability in market or in inventory. Further, we can set the material grades for bolts as required. Now, let's start creating steel columns by clicking on column icon in steel menu and then place the columns at required location using cursor. User can modify the columns profile in bulk. Just select required columns and press enter on keyboard to open columns properties window. Select required profile and click on apply to change profile. Let's not worry about the preliminary profile as it will be designed automatically by Camosis in subsequent stages. Now, let's start creating steel beam by clicking on beam icon in steel menu and then place the beam by picking the start and end location of beams at required locations. We will add both primary and secondary beams. As we have finished adding beams, let's now create roof bracings using horizontal bracing tool in steel menu. Simply click on horizontal bracing icon and then start adding bracings by picking the start and end location of bracings. Let's not worry about the preliminary profile as it will be designed automatically by Camosis in subsequent stages. In the next step, we will add vertical bracings using vertical bracing tool in steel menu. Simply click on vertical bracing icon and then start adding bracings by picking the start and end location of bracings. In this model we will add inverted V bracing type. These bracings will take care of longitudinal stability of the structure. Let's not worry about the preliminary profile as it will be designed automatically by Camosis in subsequent stages. Let's add base condition for columns. Select column nodes at column base using cross-window selection and then press enter on keyboard to open the node properties window. Let's select pinned base type from the predefined base types available. We can notice on the screen that a unique symbol representing the base type has been created. Pinned base, fixed base, roller base are predefined base types available in Camosis. User can customize base type too. Let's create girts. Right-click on Create Girt Macro to open Macro Properties window and load predefined macro preset. User can customize base girt space, girt spacing, girt profile and many other variable parameters available in this macro. Click on Apply to save the setting as default and select any two columns to create girts between them. Camosis can break the girts automatically at every column available at the intermediate locations between the selected two columns. Let's create views at grids. Simply select Grid, then right-click to select Grids and click on Create Views on Grid. We will open View at grid line B to make sure the created girts location and offset are proper. Let's create girts in remaining walls also, using last defined settings from the Create Girts macro. Simply click on Create Girts macro and select any two columns to create girts between them. Now we will create anti-sag rods in girts. Right-click on Create Sag Rods macro to open Macro Properties window. User can customize sag rod profile, number of rows of sag rods and many other parameters of sag rods. Simply click on Apply button to save the settings as default. Let's start creating sag rods by selecting the first and last girts of each and every bay. As you can see, sag rods have been created. Let us repeat the process to generate sag rods for rest of the wall girts. Generating sag rods will reduce the unbraced length of the girts to have optimum design of girts. Now, we will create a rigid frame in the direction where no vertical bracing is provided. Simply double-click on main beams to modify the end releases of main beams and uncheck the moment release boxes to have rigid frame action together with columns. As we have not provided bracings in the main beam direction, this rigid frame action will take care of the lateral stability of the structure. As we have finished the 3D model of the structure, it is time for us to create load cases. Simply click on Create Edit Load Case and Combination in Analysis Design menu to open the Load Case setting window. Let's start creating basic load cases simply using available parameters in Load Case tab. While creating the dead load case, user can have option to include self-weight in it. Also, user have option to convert the load case into mass with required factor of ratio for seismic design purpose. Repeat the same process to create other load cases for live load, wind loads. We need to use state subindex for wind load cases to have them combine individually with other cases while generating load combinations. User can create seismic loads, automatic crane loads, temperature loads, rain loads, hydraulic loads and many other types of loads in Camosis. Click on Close button to start the next step of applying the loads. In this step we will create virtual plane objects to apply area loads on it. Let's right-click on Floor tool in Model Explorer window and click on Create Floor. Mention the name of the floor as required and click OK. Now, right-click on Created Floor, then select Find Polygons and specify the exact elevation of floor. User need to make sure to select only the floor beams to create the closed polygons. As we can see in the screen, floor planes have been created, but the load distribution of polygon is two ways. We will now adjust the load distribution direction to one way. Double-click on Created Floor to open Polygon Property Editor window, use Load Distribution method and Load Distribution direction. Now, let's right-click on Created Floor again and select Create Surface Load to open the Create Polygon Load Set window. Use proper load case, load direction and load amount in the window. User can also change the input units of loads. Click on OK to add loads to polygons. To visualize the created load, make sure to activate Annotate tool, and scroll down to Proper Load Case from the drop-down list of Load Case menu. Now, we will repeat the same process for applying the live load on the floor. Simply right-click on Floor then select on Create Surface Load and we can select proper options in the window. Let's create floors on for all four walls in our structure. Simply right-click on Floor option, then click on Create Floor and give name to the walls. Let's give name as Wall at Grid Line 1. Wall at Grid Line 2. Wall at Grid Line A. And wall at Grid Line C. Before creating polygon on wall, let's hide the unnecessary objects in the wall to have hassle-free polygon creation. Let us change view plane using the To View Plane tool in View menu. Now, we will use Select Objects between Planes tool in Edit menu to select objects in the wall. User need to make sure to select only the beams to create the closed polygons in between them. Next, we will right-click in Created Floor, named Wall at Grid Line 1 and select Find Polygons. Just enter the Z value as 0 as view plane set to origin of wall. As we can see polygons have been created, let's repeat the same process to create the polygons for rest of the walls. Let us change view plane using the To View Plane tool in View menu. Now, we will use Select Objects between Planes tool in Edit menu to select objects in the wall. Next, we will right-click in Created Floor, named Wall at Grid Line 2 and select Find Polygons. Just enter the Z value as 0 as view plane set to origin of wall. As we can see polygons have been created. Let us change view plane using the To View Plane tool in View menu. Now, we will use Select Objects between Planes tool in Edit menu to select objects in the wall. Next, we will right-click in Created Floor, named Wall at Grid Line A and select Find Polygons. Just enter the Z value as 0 as view plane set to origin of wall. As we can see polygons have been created. Let us change view plane using the To View Plane tool in View menu. Now, we will use Select Objects between Planes tool in Edit menu to select objects in the wall. Next, we will right-click in created floor, named Wall at grid line C and select Find Polygons. Just enter the Z value as 0 as view plane set to origin of wall. As we can see, polygons have been created. Let's apply area loads on created polygons of the walls. Simply right-click on Wall at grid line 1 in the Model Explorer, then click on Create Surface Loads to open Create Polygon Load Set window. Select Wind Load positive Y, next select Perpendicular to Polygon in Direction, then give a name to it and specify the surface load value and click on OK to create loads on polygons. As you can see, loads on beams are created. Let's repeat the same process to create area loads for the rest of the walls. Right-click on Wall at grid line 2 in the Model Explorer, then click on Create Surface Loads to open Create Polygon Load Set window. Select Wind Load -Y, next select Perpendicular to Polygon in Direction, then give a name to it and specify the surface load value and click on OK to create loads on polygons. Right-click on Wall at grid line A in the Model Explorer, then click on Create Surface Loads to open Create Polygon Load Set window. Select Wind Load positive X, next select Perpendicular to Polygon in Direction, then give a name to it and specify the surface load value and click on OK to create loads on polygons. Right-click on Wall at grid line C in the Model Explorer, then click on Create Surface Loads to open Create Polygon Load Set window. Select Wind Load -X, next select Perpendicular to Polygon in Direction, then give a name to it and specify the surface load value and click on OK to create loads on polygons. Now, we will generate load combinations automatically. Let us click on Combo Generator in Analysis Design menu to open Load Combination Generator window. Select appropriate code from list of codes available in Camosis. User can also have option to remove or keep any load case from the list of load combinations. Simply click on Generate button to create load combinations automatically. Now, we will review the created load combinations by opening the Load Case Setting window. Here, we can see already created load combinations. User have option to select load combinations for appropriate design use. Available options for design purpose are Use for Stress Check, Use for Deflection Check, Use for Connection Design and many other options as shown in this window. Let's click on Run Analysis to analyze the structure, then click on Check All to check all the members as per selected design code, and click on Design All to allow the Camosis to determine the most suitable profile for the members. Let us click on Color Coding to display the members in as per the design ratio set. In this example, all green color members are passed in design and red color members are failed. Now, we will review the design data of members. Select any member and click on Design Data tool to display the design data of selected member in the model. In the design data, user can find design ratios, unbraced lengths check, stress ratios and deflection checks for both minor and major axis of beams. As you can see some members shown as failed, we will now use Design Restriction option to let the Camosis to design most suitable and economical profile based on the profile criteria set. Right-click on Design Restrictions in the Model Explorer and click on Create Design Restrictions to open Design Restrictions setting windows. Let us give name as columns and select required profiles from the wide range of International Standard Steel tables available in Camosis. User can also have the option to select individual profiles as required from the option manual selection list. Click on Apply and OK button to finish the step. As we can see design restrictions for columns created, now we will repeat same process to create design restrictions for other set of members. In the next step, we will apply the created design restrictions to the members in the structure. Let us select all columns and press Enter in keyboard to open Properties window and open Design 1 tab. Then we will select columns from the Design Restrictions drop-down menu. Simply click on Apply and OK button to complete the process. Let us repeat the same process to apply design restrictions for the remaining members in the model. Let us select all beams and press Enter in keyboard to open Properties window and open Design 1 tab. Then we will select beams from the Design Restrictions drop-down menu. Simply click on Apply and OK button to complete the process. Let us select all wall bracings and press Enter in keyboard to open Properties window and open Design 1 tab. Then we will select wall bracings from the Design Restrictions drop-down menu. Simply click on Apply and OK button to complete the process. Let us select all roof bracings and press Enter in keyboard to open Properties window and open Design 1 tab. Then we will select roof bracings from the Design Restrictions drop-down menu. Simply click on Apply and OK button to complete the process. As we have updated the members with design restrictions, let's analyze the structure again. Click on Run Analysis icon, then click on Check All to verify the members as per selected design code and click on Design All. Let's click on color coding to display past and failed members visually on screen. To change the members to the most suitable and economical profile, select all members in the structure and press Enter on the keyboard to open Properties window and click on Replace with Design Sections in Design 1 tab. A pop-up window showing message about updated members quantity. As some of the profiles have been changed, we need to re-analyze the structure again. Simply click on Run Analysis, check all and design all icons consecutively. As we can see on the screen, all the members turn green color, indicating that all the members are passed with most suitable and economical design. As we can see in the utilization ratios and other design data, members are optimized to best suitable profile. Utilizing the Design Restrictions option in Camosis will save lots of time in optimizing the structure and get most economical design. Now, let us focus on one more useful tool for Designer, which will give graphical visualization of stresses occurred while doing analysis. In the Analysis Design menu, click on Forces icon, which shows list of available internal forces of elements. For instance, click on M33 to display diagram of major axis bending moment on screen. The bending moment diagram can also change instantly as the load case changes. Camosis can show graphical diagrams for shear, axial compression, tensile forces. This force diagram can also be shown in solid and line modes. Camosis have another handy tool for designers, which is Element Output in Analysis Design menu, using which designer will be able to see forces and deformation values for members individually or a set of members or joints. Let us select a beam and then select Frame Element Internal Force Diagram option from Element Output tool. As you can see, user can get the measurable diagrams for bending moment, shear force, axial forces and deflections. User can also have the option to change load cases. This tool will help designer to understand member design even more clearly. Similarly, user can use Joint Frame Element Analysis Output Table tool to see the reactions, displacement and spring forces of nodes. This tool will help designer to understand the structure more clearly. As we have finished member design, now we will do connections design in Camosis. Select all members in the model and click on IntelliConnect in IntelliConnect Plus menu. As you can see, the Camosis is automatically generating relevant connection based on user-given priorities. Camosis have the ability to generate highly accurate connections, which mostly does not require any further editing, which will save lots of time in designing, detailing of connections and generating shop drawings. IntelliConnect will generate connections based on the user-defined standard detailing parameters. Now, we will review connection designs. Let us go to View menu, then click on Color Coding icon and select Connection Design Ratio Coloring. This action will make all connections elements to appear in 4 set of colors. Obviously green color is design passed, red color connections are designed failed, yellow color is not checked and white color means unrelated. We can also generate connection design report easily. Select any connection, then right-click, click on Connection Design Reports and select Connection Report with the required code. As you can see, a detailed report about the connection is generated and opened automatically for review. User can find connection diagram, design properties of connection plates and bolts, actual and allowable forces and some other useful data in the generated reports. Let us generate report for another connection, for instance. User can also see the summary of connection designs by clicking on Design Summary in Drawings and Reports. Using this report, user can locate the connection in the model simply by double-clicking on any connection in the list. Now we will generate design reports for members in the model. Click on Analysis Output in Drawing and Reports menu to open Text Report window. In this window, user can choose different option to get design report as required. User can select the location of reports. Click on OK button and open Project Folder location, then open Output folder to find the generated design reports. Let's have a glance at generated reports. A detailed design calculations report showing material weights, summarized design results, detailed design results, internal deflections, displacements, internal joint forces and reactions, and many other useful results. If you have any questions or clarifications, please do let us know. Thank you.